2018 in Sendai, Japan, while I was working on developer acceleration and productivity at Shopify. That team handled everything from when you touched your laptop to deploying and everything in between. It was part of a larger organization called production engineering. And so we would kind of like touch this little slice of the pie across the entire DevOps stack. While I was working on that, I specialized in CI at one point, and then software to manage developer laptops, which is essentially like 1,000 manually configured servers that never work. And so between doing tests, CI, developer environments, and pretty much everything else, we interacted with the developer quite a lot and found, and I came up with this concept that I think really impacts the ability of developers while interacting with DevOps software called cognitive overload. And so we're going to be talking about cognitive overload and its impact. I'll be touching on that by talking about unit tests, but not just for business logic. And then I'll finish it up with talking about an engineer's favorite topic, writing English. So cognitive overload and impact. Cognitive overload is the concept where being given too much information all at once results in you being incapable of processing or retaining that information efficiently or at all. Ironically enough, this presentation is a cognitive overload of sorts, since I'll be rambling at you for 15 minutes, potentially incoherently. And so cognitive overload in an organization has many, many types. You can experience it in many areas. We saw in Cheryl's talk, as you're implementing tools and tools and tools, some of her teams were not able to keep up with the new information and became cognitive overload, cognitively overloaded. And so, in my experience, cognitive overload in like an internal DevOps team could resulted from something like this. Don't add this package named foo. Make sure you put a space after or before the curly brace in a block, but not in a hash. That's very important for some reason. Make sure you include a file in all test files so the tests run better. Make sure you document your public interfaces, but not your private interfaces, but sometimes your protected interfaces. Make sure you name your files in the convention we have somewhat arbitrarily decided. Also, you need to remember that decision every single time or CI is going to fail 30 minutes into the run. Make sure you kind of get the point, right? We make a lot of decisions every day. I once heard that we make 35,000 decisions in a day. That's a lot to do. Do we really want our developers taking all of those decisions to determine whether or not to put a stupid space after a curly bracket? Like, it gets old really fast. People aren't going to remember all of this. We build software to automate tedious tasks. Can we automate our own pain away? Probably, but I want to take a question and ask what happens if we don't. If we don't, developers have to remember a list of tedious things, which takes away from things that are more important, like writing software. Humans are really error prone. I make probably more mistakes than I correct in a day. And people are going to make mistakes. I don't think I push a pull request without having linting yell at me. And communication is really hard, right? If you send out a memo or an email or the infamous @channel in a Slack group with 450 people and then you across 14 time zones, people aren't going to read your message and they're not going to read your email because there's just too much. And now your application is broken because somebody made a mistake. And it's not their fault. There's just too much for them to know. And so I asked myself, I'm like, when a logic error is found in the code base, we reach for a unit test or an integration test or some sort of test. But when it's a project or infrastructure mistake, we reach for documentation, talks like this, best practices, little mantras where we're like, move fast and break things. And then we update our contribution guidelines and assume everybody's going to read those every single time. That's just not really great. Nobody's going to really do that all the time. And so people get overwhelmed looking for this information or trying to remember it. And so I asked myself, can we make this testable? And so I came up with these simple things to fix a problem. First, you need to identify the problem, right? Then you can determine if a fix can be automated. Cheryl, rightly said, you can't automate everything, but that's fine. Can you detect certain output and match on that, right? Can you read a project file to check something? Can you parse or lint it? Can you run the program and check some state afterwards? Then you can implement a test to detect and automatically fix it. But if you can't fix, educate. So the unit test, but not just for business logic. So in many applications, all right, let me take a step back for a second. I'm going to use a scenario for most of this presentation. It's a pretty simple one about missing test files. And so in many applications, there are classes that require corresponding tests. My background is both Shopify and GitHub, so I'm like Ruby to my heart. So forgive me because I don't have types, so our errors are different. Assume a class is named myClass.rb. And there's an associated test called myClassTest.rb. Sometimes a user doesn't name it correctly or forgets it or doesn't add it. And so you end up with like myClass with 3 S's test.rb by mistake. Not that big of a deal, but sometimes it is. Oh, this is fun. What was that slide? Oh, it doesn't like any of my pictures. Oh, that's fun.
Maybe we can kill Wi-Fi and bring it back again.
Maybe.
Zoom it and show the slides directly without full screen.
No, I mean the slide doesn't know the picture.
Oh no.
Okay.
Maybe it is Wi-Fi.
Can we? Where does that like start?
Hey Julian, you brought a whiteboard, can you just draw them out?
Actually, yeah, if you do new tab, we can try that.
Next time I get a talk, I'm just gonna
Hey.
slides.
Cool. And so this is really small and you can't read it, but that's cool. This is a test that I wrote to determine if there's a missing test. And so the first thing is at the top, right here, I find all files. And so this specifically is, I wrote database seeds at GitHub, and I wanted to make sure that every database seed had a test associated to it. And so I first found all the different seed files. I then went through and just like smashed _test.rb at the end, because that's what Ruby does, is their little convention. And if one of those is missing, then I craft an error response down here being like, hey, this is broken. And so this is what ends up getting outputted. First, right here, I explain exactly what the problem is. You are missing one file that is expected to have a test. It's pretty straightforward. But I don't just say like, hey, this file is missing a test. I say, you're expected to have a test here. This is the file that's missing the test. And I expected the test location here. And this is actually really important, because maybe that user has it tested somewhere else. Maybe for whatever reason, it's typoed, maybe. This helps the user understand this is exactly where I expect it, and so they have a very actionable output of let's go check that location or add a test file there. I'll come back to that scenario in a little bit to explain a little bit more. Other areas in the unit tests that I found to help was I would take the entire project, not just like a class or a method. I would literally just shove the entire project, potentially just the string of the code, into a unit test itself, and or like launch it. And so one example is I took an application and I launched it. And then once it's launched, I went and like inspected it using whatever tool I can do with that, and wrote a unit test to assert that only a specific set of files was loaded. And the reason for that is if we added more files, the boot time would be slower, which would, when you have 1,000 developers, a 1 second increase in boot time is 1,000 seconds or however many hours, probably like 2 developer weeks per week from a 1 second increase in boot time. Or I would assert like all packages are sourced from approved locations, so people weren't bringing in like Git gems that were causing a lot of authentication issues. Or that maybe malicious package is not included in dependencies or subdependencies. Or one of the other things that I did is in Ruby, Python, JavaScript, there's a lot of packages that do the same thing. You don't want 17 different HTTP clients, and so you typically will choose one, and then the rest of them you're like, don't use that. And so what I did is I actually wrote a test that would parse our gemfile.lock with Bundler's API, which is Ruby's dependency manager, and say like, hey, you've added HTTP party, that's a banned gem. It's banned because we already have Faraday. Please go use that. We don't need you to add another dependency. But I didn't stop there. I said, we don't like adding more dependencies because it increases security surface, it decreases boot time, it increases this. We iterated through it and said, here's a solution instead. And that was really important because it explained to the user what was going on, and it took a moment to educate people. You can't automate that away, but you can definitely educate them of why that's not a great option. And so this is our favorite portion. It's when I talk about writing English. Or not quite yet. Rubocop is a static code analyzer, or linter. It defaults to the Ruby style guide. This is the fancy tool that will automate like those spaces that we don't care about, or like the tabs and all those weird rules that are stylistic mistakes or security issues, mistaken code use, stuff like that. I actually consider it a form of documentation because it documents how your code should be laid out within your application. Both Shopify and GitHub actually have their own style guides and their own, they're called COPs, that go and find specific use cases. And this will allow us to do things like introduce new paradigms into the application and make sure people can't use the old ones without encountering a linting error, which means that we tell them right at the moment they write that, like, hey, there's a better way, go use that. And the best part is it automatically fixes a lot of mistakes. And so when users make mistakes, according to the guide, Rubocop will explain the correct usage, which is very beneficial, might I add, particularly for more junior developers or people that are onboarding to the language. I work with senior developers, other senior developers that are new to Ruby, but they have tons of experience in Python or Java. And so we don't want to consistently slap them on the wrist just because they don't know our specific style guide. There are problems. Errors aren't always easily understandable, and users should be able to override with a judgment call, which you can do. So if you're not using linting, that is definitely something under documentation I think is great. And this is one of my favorite topics. I call it just-in-time education. I kind of alluded to it throughout the rest of the talk. Just-in-time or JIT education is kind of similar to JIT compilation, which is a computer science topic. And it means, JIT compilation means you only compile things as you need it. JIT education touches back to the first time when I was telling you about being cognitively overloaded. It means to only provide education or information exactly at the moment you need it. Linting is a perfect example of this because it tells you as you're writing the code, like, hey, this is wrong. Other things are like unit tests where you can detect gems, like I mentioned, or adding things to the boot path. There's easy ways around it, but it gives you a moment to educate your engineers at the exact moment it happens. Other cases we've used this in is like Kubernetes deploys, like metal deploys or cloud deploys, where you get this big long error and you're like, what the f is that? And then you kind of parse it, automate the output, and be like, oh, this error probably means this. Here's the original output if you want to see it, but like, you probably want to do X, Y, and Z. Or even better, automate that X, Y, and Z. And so this reduces cognitive overload as you get the information just in time instead of all at once. And so I made a handy guide. Should I write a memo, doc, email, or @channel in Slack? Does everyone need to know the information all of the time? No, that's cool, but now because nobody interacts with it all the time, they're going to forget it. Yes? Well, that's fine, good luck, because nobody's going to remember it because there's too much information. And so in a very passive-aggressive way, they both say just use just-in-time education. It's a really passive-aggressive and crappy joke to say, like, information should always be given just in time if you can, because otherwise people just aren't going to remember it, because they're either getting given too much information or they don't remember it 3 months down the road when they actually need to use it. And so JIT education is detecting when the user needs to know something and then tell them, A, what is the problem? Example, we can't create a database record for you. 2, why is this a problem and what are the implications? Your database won't be fully ready for development because you're missing X. And how can it be fixed? You need to fix the validation problems. And one of my favorite things is saying, is it a code problem? Maybe it's fixed on master, which is usually enough for people to go, oh, I should do a git pull. And then it's fixed. And then they don't come into your Slack channel and have like 650 people asking you, why is the thing broken? And it's like, just pull master. This is crucial when you have 1,000 people in your team and they're all coming into your Slack channel. And now the user, the goal is like the user needs enough information to figure out how to fix it themselves to like give them that power. And so that's what this does. And so back to the scenario, with the one-to-one mapping. Typically, in my experience, this is so you can run tests and development a little bit easier. So it'll be like, oh, this file changed, so we'll run this test. Or you can run a subset of tests in CI to reduce computer usage. And so if you add a new file called foo.rb, you expect it in foo test, but they added that foos test with an S. And so I have bad and good examples. And so if you say, we expect file foo.rb to have a test, the user might be like, I did add a test. It's like right there. And then they get frustrated because they can't figure it out. But if you say, we expected foo.rb to have an associated test at foodtest.rb, but we couldn't find one, that gives them more information to figure out where the problem's lying. And they can be like, oh, I see, I typoed it. Then you tell them, then it's like, don't just tell them, please fix this, because then you're just adding another stupid random rule that no one wants to follow. Instead, tell them why. At that time, it's a just-in-time education thing. If you don't put files in the expected spot, it can impact CI and local development, blah, blah, blah. And then the user has enough information to go like, oh, that's the impact. Because they're not stupid, they just don't know, they didn't see the memo, right? Make sure you tell them how to fix it as well. Like, don't tell them nothing, because then they're like, I don't know what to do, potentially, because they might not have noticed the typo. And so you could say something as simple as, rename any misspelled test files, or add a test if you missed one. And that could give them enough information. You can, of course, expand this to more advanced examples. The last thing is about installing dependencies. If you take a look at this example, this is a GCC output from Bundler trying to install RMagic. This is like a garbage file, like garbage fire, because like there's like so many negatives. Up here it's like magic config, no, like I don't know if this is negative, negative, this is actually a negative, so it's a positive, this is negative, and like I've read like thousands of these, so I know this is the line that you actually want to look at. It's missing magic1.h, which actually means it's missing ImageMagick for version 6.9 or greater. Right. Sorry, I think it's 6.9.0.a or greater. And so I actually wrote something that parses this and says like, we couldn't install this version. This is likely because the version of ImageMagick on your computer is incompatible. You need ImageMagick 6.9.9-40 or greater. See, I didn't even remember it. And like, who the fuck's gonna remember that? Like, right? And so you get this output and now you have to Google. So instead it parses it and then like uses JIT education to be like, here's the problem, here's why it's a problem, what can I do? And I actually have this available under this repository if you do want to use it. I'm trying to add it into Ruby Gems, but it's a very long RFC process. I'd like to do this for more like homebrew and stuff as well, but I just don't have time. Yeah, and so quick overview. People can't remember everything. You've probably forgotten most of this presentation. We can automate unit tests and analyze the project for users, and then remember to do the tedious stuff for them. We want them to code, not write spaces after a bracket. And we can use these moments to educate people with information just in time. And we'll see if the last slide actually works. But thanks.